Alright, hello everybody, this is Antonio Wolf. Somebody asked in the comments in one of my previous videos what I think about Wittgenstein. And I actually like Wittgenstein quite a lot. There was a time quite a while ago, where I had a sort of a bit of a Wittgenstein phase. And it was also happening at the same time that I was getting into Marx, which, you'd think that'd be a weird mix, but not really. At least at the point where you're not getting into like weird metaphysical stuff, Wittgenstein and Marx actually combine pretty well, I think. Marx's whole focus on materialism and, trying to keep things real in that way. And Wittgenstein's focus on, just cutting through the bullshit of obfuscating language. Goes together pretty damn well. By the way, speaking of Wittgenstein, Marx, and dialectics, perhaps if you've looked around, you might have seen that there's a website called like anti-dialectics, like .co.uk or something, run by somebody who has the name Rosa Lichtenstein. I don't know how to say their names. It sounds like a Jewish name. Who knows? I used to think that was a woman, but some people say it's a man. It doesn't matter to me. Either way, it's pretty funny because, for the most part, if you take the standard view of dialectics and of Marxism that pretty much the majority of Marxists have, all of Rose's attacks are spot on. The obfuscating bullshit, the meaningless terms, all of this stuff just comes crashing down under a Wittgensteinian attack about what do you actually mean by all this weird language? You mention dialectics here and there and everywhere, and what the heck does it mean? So, yeah. After I figured out what dialectics were, I don't agree with Rose on that. But other than that, if you have the standard view like Marxists do, well, a Wittgensteinian attack works pretty well. Anyways, that aside, that website is ridiculous. Perhaps you're not acquainted with the world of crankery and crank websites, but it's a crank website. It reads just like one. It's so repetitive. It has so much just splattered all over the place. Literally, there's nobody in this world that could really sit down and read all the crap that Rosa has written. And it's certainly not worth reading that crap, even if you could. So, just a bit of a heads up there. Anyways, just going back to Wittgenstein in general. So I like Wittgenstein. The main things I read were just at the beginnings of the philosophical investigations. And that book is great. There are very few books I think that you could just tell somebody to begin philosophy with. That's one of the books that you can, I think. Sure, there's certain mentions of certain things that you should go get background on, but for the most part, Wittgenstein is just kind of posing the question of, well, what do we think about things this way? What happens then? Does it make sense? Can we actually do that? And so, particularly on the question of language, that's kind of what happens. I never finished reading philosophical investigations. I just had other interests at the time. I was more into physics, and I was going more into Marx, and so I just put that on the side and never quite went back to it. Nonetheless, the attacks on the obfuscations of language stuck with me ever since. And, I keep that in mind. And I think part of the reason that I like Hegel quite a lot is that Hegel kind of also does that ripping through the bullshit of obfuscating language. Despite what most people feel about it, which is to say that they think Hegel uses obfuscating language and it's it's so abstract and, nobody's ever sure what he means. That's bullshit. Hegel's a completely technical writer. Everything means a very specific thing, and if you know how everything relates, anywhere that he mentions anything, you should be able to pretty quickly be able to ascertain what exactly is being said, why it's being said, and how it's working. So there's that. I also had a bit of a like with Wittgenstein because, funny enough, when I got into Marx and Wittgenstein, I basically had an anti-philosophy phase in which I sort of teetered towards mysticism. And mysticism is very anti-philosophy. It's not about reason, it's about experience, intuitive experience, which is ineffable. And, Wittgenstein has some things which I've always liked come out of his Tractatus, which are interesting in that way. For example, there's a section on the Tractatus where he talks about Solipsism and about how, the true meaning of Solipsism is really that if there is no external world, there is also no difference between myself and the world. And so what Solipsism does is actually extend the self into the world itself as a totality. So, there's no difference there. It just leads to monism. Okay, there's nothing really bad about it when you really think about it. All it does is basically get rid of that distinction. There's no distinction between self and world. So that's interesting. Stuff about language games. Yeah, I like it. If you're going to rip empirical concepts, and if you're going to rip, insubstantial rational concepts, it's a very good attack, in my opinion. It's not even in my opinion. It is a good attack. It's pretty much impossible to defend against it. If you're an essentialist about, say, gender, and you're trying to specify the essence of gender. All that the Wittgenstein has to do is say, well, where are you getting this notion from? Look at how people use the word, look at how you use the word, and realize that there is no set definition, that there is only what he calls, these things, family resemblances. So for regular concepts, that works really well. For stuff that's unfounded, that works really well. For other stuff, it doesn't work so well. And that other stuff would have to be purely self-grounded rational concepts, the likes of which Hegel has. And he's not the only one, but he's definitely the biggest one that's consistent with it. In which the question of what things are for Hegel is actually very much somewhat in line with Wittgenstein. Wittgenstein says language is use. Hegel would say, yes, actually that's true. What things mean is how we use them, but how we use them is what we do with them. So for Hegel, there's an intimate connection, which is inseparable, between being as passive, being as just a being, a thing is, and being as a thing being actively. A bike is a bike, but when a bike is being a bike, it's doing what a bike does. It's executing its function, so to say. So since I understood that part of Hegel, I've always thought it was actually very, very interesting. Very, very interesting. And so once you get to logical stuff, which is, Hegel's big thing, you don't get this whole game of family resemblances anymore. You know exactly what you're talking about because you're building things out of actions. And because you objects that you make objects are exactly the actions that you've operated, you always know exactly what you're talking about. There is no question of like, oh well, is that really what we mean by being, looking at other places in the world? No, you know exactly what you defined as being, and it's not just because you decided to arbitrarily define it that way, but rather you're beginning with logical structures and operations which for themselves, if you just let them be, will do certain things, executions. You know, the concept of being, when you enact it, when you activate it, when you run it through its own logic, cannot help but be nothing. You know, that's just the nature of immediacy as such. So that's pretty interesting. What else? Somebody else asked about expanding more on what I said in the Hegel and science cruise. And oh yeah, they asked me to explain what I meant by saying that life transmutes elements. Nothing spooky whatsoever, by the way. All I meant with that was really to say that life enacts chemistry. It orders the chemical operations around for its own purposes. It's not talking about transmutation of gold, from lead or any such thing. I mean, I like alchemy. I find it interesting, at least the philosophical side. I have no care whatsoever about, the silly pseudo-chemistry that the so-called puffers, the alchemists who were actually trying to do silly things like turn lead into gold, were doing. But there is a philosophical understanding of alchemy, which is actually pretty legit. It's actually very philosophical. There's a lot of meaning to that. So yeah, that's me on Wittgenstein. Not much to say because frankly I haven't read very much. Oh, there's my dog. I haven't read very much from Wittgenstein. There is one thing that I'm interested in beyond language, and that is Wittgenstein's views on mathematics. And hold on, let me let my dog go outside to roam. So yeah, Wittgenstein on mathematics. There is a book he has on his thoughts on math, which is called Math. And I looked through the Stanford Encyclopedia article on that, which is interesting. And Wittgenstein has some interesting things about certain numbers and operations. For example, Wittgenstein thinks that irrational numbers aren't numbers. He thinks that they are, in fact, functions. God, my hair is just a mess. They are in fact functions. So, say something like the square root of 2 is not actually a number because it never terminates. So therefore, the function of what the concept of number does never actualizes. The number is supposed to give you the definite bound of the quantity, but irrational numbers do not do that. Therefore, they cannot be numbers. Therefore, what do we call them? Well, we say that the square root of 2 is actually just a function. That's it. So that's actually very interesting because I've always had this perennial fascination with mathematics, and about the last 3 weeks, I've kind of really gotten into that. Didn't plan on it, it just happened. As with most of my interests. And so I started learning about math, and there was a video that I I watched about why a negative times a negative equals a positive. And all of a sudden it dawned on me that that makes no fucking sense. When you think about it in the ways that we were taught to think about it when, you know, we were growing up, all the way from children to high school, and, you know, even the beginnings of math in college was something like calculus. You know, beyond calculus, things start getting weirder and weirder, in which it's harder and harder for people to say what the actual meaning of certain operations in an intelligible sense, in the sense that we have a quantity and we know what's being done with that quantity, you know, how it's being put together, or how it's being broken apart, how it's being related. It becomes increasingly difficult to state what is going on. So anyways, I got interested in that. All of a sudden that came to mind. I had that in mind for a while. Actually, it wasn't the first time I thought about it, but I hadn't really paid attention to it until this video, in which I saw why it didn't really make sense. Because the proofs for why the negative times the negative equals a positive are purely formal, and nobody can ever really explain what it means. You know, when you multiply, say, 3 times 3, you know that what the second 3 tells you is to repeat the operation of the first number 3 times. And the regular number 3 actually stands in for plus 3. You know, its real meaning is plus 3. We don't really have neutral numbers. You know, the positive numbers have no sign, but the implicit sign is always the plus. It's a sum. So, you know, 3 times 3 is sum 3 times. Plus 3, plus 3, plus 3, 9. Okay. Negative 3, you know, times 3. It's repeat the subtraction 3 times. Negative minus 3 minus 3 minus 3 equals negative 9. Okay. What the hell does plus 3 times minus 3 mean? Think about that. What the hell does that mean? If with the regular number you were just supposed to repeat the operation by the number of times the number, that's easy. But what does the signed operator mean? You know, what does 3 times negative 3 mean? The repetition is to be done how? It's actually not that easy once you try to explain it. It really isn't. It's the same thing with a negative 3 times a negative 3. You know, why does a minus minus a minus make a plus? And it's not so simple. I mean, yes, you can find explanations, but when you actually think about it and you try to expand it to the entire meaning of the signs, it doesn't make sense. The operation, according to the conceptual meaning, does not stay consistent. So those things are in mathematics, and I find that fascinating. And in that video that I watched, the second video, about why minus times a minus equals a positive, where the formal proof was shown, somebody posted this very interesting book called Negative Math, how to bend mathematics positively. And it's a book about the history of negative numbers and how they were an immense controversy all the way to the 1900s. There were still top-level mathematicians, you know, bringing up this issue about, well, you know, look at what we've done. We've developed algebra so far. We've created all these other new mathematics, and yet we still have no clue what the meaning of the signs really is. Fascinating stuff. It's a very good book. You don't need to know beyond basic arithmetic to understand what the issues really are. It's very, very clearly written and very engaging. You know, it just brings up so many issues of the different ways that people try to answer it, the attacks against it, the attempts to save it. And ultimately, it's about how mathematics stopped being a science of quantity. That the realization that negative numbers just screwed up so many things if we kept thinking that numbers were quantities, and if we kept thinking that the signs were talking about operations of quantity, just made it incredibly hard to ever talk about what really is going on. And so mathematics in general just gave up on trying to have any intelligible content, and became simply a science of formal coherence, a formal operation. And therefore, whatever you can carry out within the formality of the functions of identity in mathematics, while you could not have in real life, say, x squared plus 1 equals 0, because that ends up leading to x equals the square root of negative 1, which is an impossible quantity, as well as, say, negative numbers, which are impossible quantities. For example, 5 minus 8 is not possible. Nobody can do that. You can't take 8 from 5. So negative quantities are physically impossible. You can then transfer the problem and say, oh, no, it's about representing ideal quantities like debts. But now you shifted away from one ontological order to another to explain the mathematics. And this is actually what happened in the history of those controversies, that the operation and its meaning kept being changed in order to try to save that it had any conceptual meaning, until finally it was just given up on that it could not have conceptual meaning, because too many things happen in mathematics regardless of what you do to save it that are possible because they are syntactically valid, they're grammatically right. If you ever heard Chomsky talk, there's a Chomsky talk where he talks about green dreams run furiously or something, and he says, look, that's grammatically valid, but it's a meaningless sentence. That's basically what math did and what it has become. It has allowed that all it cares about is formal validity, the syntax, and whatever that means is inconsequential. The meaning is simply going to be the fact that you could do the operation consistently with the rules laid out for the fundamental mathematics. And so anyways, I got really interested in that. I read that book in about 2 days. Really, really fascinating. The first half is about the history. The second half is about what happens when we just go ahead and let minus times minus equals a minus. It solves a lot of problems by just not letting the problem exist in the first place. There's no question about, well, what does this mean? Because we've already given up that it has any meaning. But then it leads to some very funky new mathematics. And the book is fascinating because you basically learn how to make math. And that fascinated me forever. I hated mathematics when I was in school, but I still always wondered, how do you make new mathematics? How do these people do it? Because I watch people on the fringe all the time, and they come up with new mathematics. It's fascinating, and I've always wondered, how do you do it? How does one do that? I mean, they don't come up with, say, new operations so much as they redefine certain things on top of the older operations, and therefore create new mathematics. Stuff, say, like quaternions don't function with the exact same rules as classical algebra. It has itself a new algebra. Vector mathematics takes on that and simplifies it, but it's a new kind of algebra too. There's a guy I watch on YouTube called Stuart Stinty, I think, and he's an electrical engineer, and he came up with this new form of mathematics called vortices, which are a derivative of vector calculus, or vector algebra, actually. And it's fascinating. They just do it. Anyways, reading this book and reading the second half, it dawned on me, hey, so he's starting here from the beginnings. Let's see if I can play around with a bit of the math rules and try to do a Hegelian dialectical derivation of the mathematical form and objects. And the last 3 days, I have just been furiously writing and rewriting notes about how you can go just from the simple concept of quantity to the concept of number, to the concept of count, to the concept of the sum, to the reflexive concept of subtraction, to then the concepts of sign. And as I had expected, the sign is the hardest difficulty right now, because the meaning of the signs is not immediately apparent until you've worked out a little bit into multiplication, and now you're wondering, what does 3 times negative 3 mean, given a conceptual definition of what the sign does to the repetition. And I have something in about like 10 pages of typed notes on my thoughts of how we can do that. And it's fascinating because I didn't think that was possible. Hegel didn't think that was possible either. You know, Hegel says he thinks a speculative mathematics is possible, but that such a development would probably be the hardest thing to ever do. And it would also be the most worthless, because nobody cares. The point of math is that it functions, not that it's intelligible. We don't really care that it's intelligible at all. Nobody cares, really, except weird people like me. And you know, people who are first presented with mathematics and they're trying to wrap their hands around what the fuck it means. So to give you a sketch of what I was working on and what I am working on, I took one concept from Hegel and I ran with it. And so Hegel says in the Science of Logic, right off after the end of the first section on being, which is quality, that quantity is the indifferent difference of quality. And of course, at that point, you actually can't legitimately use the concept of difference, but who cares? We know what we're talking about. You know, even if you don't mention it, it just makes it a bit easier to grasp on to what's going on, even though you could without it. Okay, because think about it. If you have a quality that is different to itself, that difference is not qualitative. That difference must be quantitative. You know, one apple is not different from 2 apples in being an apple. It's different in the quantity. So, okay, that makes sense. It's the indifferent difference. It's indifferent because the quality doesn't matter. It's different because the quantity does. It's also indifferent because it's still quantity, and yet quantity is different to itself. Pretty crazy. Okay, so we have that. And so we have quantity as such. You know, we just say something is quantitative. Then we ask, okay, what's the quantity? When we answer what's the quantity, we are basically running through the logic of quantity. You know, what does quantity do? It compares quality according to the quantity. It quantifies. So, you know, if you have 1 apple and 1 apple, it's 1 and 1, 1 equals 1. They're the same, but they're also different. You know, you could also say, well, it's not the same one. Math actually doesn't care about that. It's funny that way. But anyways, so you quantify quantity, which is you ask, well, how much? You know, what is a quantity that is actually there in what is quantitative? And what do you offer? Well, you offer a number. You know, as you say, there's 2. Well, that's the number of the quantity. So the quantity is indeterminate. The number is determinate. The number is determinate quantity. And determinacy is simply the fact of definition. When you define things, say you have you're in the void of space, and somebody asks you if something is there. You can't say yes or no immediately because nothing is popping out of the darkness. Suddenly you see a point of light, and now you have something determinate that's stood out. And now you can say, ah, yes, there is something. Before that, you know, you can't really say anything other than, well, there's nothing. The only thing that stands out to you is the opposition of this emptiness to your own being. So take determinacy to mean definition, to mean something that, you know, pops out and you can notice and you can hold as object, either mentally or mentally or physically. It doesn't matter. So okay, thinking about number. Well, you know, that's just the concept of number. We're not specifying yet a number. We're just saying, well, you know, if you quantified quantity, you would offer a number. You would offer number. If you want to offer a number, you would have to offer a determinate number. Well, how do you determine the number? Well, you know, you have to objectify the quantity. You would have to quantify the quantity, and therefore you would have to number the number. So if you number the quantity, two ways that you can go about it, 0 and 1. You can say, well, there's no quantity and there is a number for that. We call it 0. Or you could say, well, there is a quantity and there's a number for that. It's 1. I think it's neater to start with 0, so you could actually go, okay, there's no quantity, 0. Well, we've objectified that non-quantity into a quantity that into a quantity representing. It's hard to talk about this without like just going in circles with the concepts. So when you quantify quantity, you offer a number. If you offer a determinate number, now you have to determine the quantity. So you know, you actually go through the trouble of quantifying, and you say, okay, there is no quantity present, 0. Now if you are clever, you can do this. You can do the operation on itself. Now we have 0, and you ask, well, what's the quantity now? Well, now we have one quantity. That quantity is the 0. So then you recur that again, you know, you run the operation on itself again, and you say, okay, well, what's the quantity now? And you have 0 and 1. Well, how many objects do you have? 2. All right, and you recur that, and you have, okay, how many do we have now? How many numbers? You have 0, 1, 2. You have 3 numbers. You recur that, and you can generate the entirety of the natural numbers just by running this operation of numbering the number. And that is the process of count. Pretty neat. Now, count obviously ends up being represented by the same symbol as number. And if you want to use, say, something like Hegelian jargon, you would say that count is the truth of number, because when you number things, you're actually determining the count. So you know the count, the number of 1 is actually the count of one quantity. The number 2 is the count of 2 quantities. And so count is kind of interesting because it begins with the numbering of numbers. And you know, when you have, and it's also a recollective function, you know, it produces numbers. You know, you have 0, and you say, well, how many do I have now? 1, and so you number the number, you have a count. And then in the count, because the count is a collective function, there is imminently something going on. How is the count collecting the quantity? How is it collecting the number? Well, it's that operation we call sum. And so sum is the count of the count. Because when you count, say you have the numbers 1, 2, 3, 4, 5, what count counts is 1, 1, 1, 1, 1, 5. And it's represented by the number. And when you sum, say 2 plus 3, what you count is 1, 2, 3, 4, 5. So just as the count counts the number, when you sum, you count the count. So 2 plus 3 is simply the total count of 5. Pretty interesting. And if you subtract, with subtraction is where the difficulty starts to come in, because subtraction is obviously the inverse operation of the order of sum. So sum is a unifying function of collection, Sum is an excluding function of difference. And there are ways to start making sense of that in multiple ways, which, as I've been working through it, makes sense for that certain order until you start getting to the next order, which is the orders of multiplication and division, and now you have trouble. You start to get a certain trouble with the meaning of the operative minus and plus signs for sum and subtraction, and you also start getting problems with what does that sign mean when a number itself carries that operator within itself. And so negative numbers and positive numbers become very interesting because there is a way, it seems, I'm not yet sure, I need to work on it quite a lot more, that you can make perfect sense of y plus and plus make a plus, and y minus and minus make a plus, and y minus and plus make a minus, and y plus and a minus make a minus. There's an intelligible way to make that make sense. You will then have still problems with the difficulties of what that will end up meaning for, say, multiplications, because it makes multiplication a bit more difficult to keep track of. It's not as simple as it is now. Although, like, functionally, it seems to end up that same way. When you write, say, plus 3 times negative 3, it's like reading a sentence. Like, the signs actually mean something, and you can actually spell that out verbally as to what the function fully means, and you can make intelligible what is actually going on. You will still get problems, say, with the weirdness of the square root of -1, but I think there might be a way to actually make intelligible what is going on in that operation, what that operation actually means. But I have a bit of a ways to go with that because I still haven't worked out how to work out the meaning of the exponent in relation to the multiplication. Obviously, the exponent is the multiple of the multiple. Easy, no problem, no question about that. And then the square root or the root function is the inverse of the exponent function. So, it's very nice, it's very simple. Stuff, say, like negative exponents, that's going to get very, very difficult very, very quickly. In standard mathematics, the way that notation works is pretty weird and just arbitrary, but whatever, that's how it's defined, and there is a sense to the way it's defined and that relationship, so it's not entirely unintelligible, and it's not stupid, but you could say it could be a bit cleaner. There could be other ways to bring that notation into a meaningful sense. But anyways, I have a medium draft that I'm working on for that, and I'll be working on that until I get bored of that. Who knows when I get bored of that, because beyond just this little attempt, and I'm not thinking I'm going to remake mathematics or anything, I'm doing this as for a thinking exercise, and when you do these kinds of things, it really makes you think, because you really have to put yourself in that seat of rigor, and you have to catch yourself doing weird stuff that at first makes sense, and when you run through it, you're like, oh wait, God, no, that doesn't make sense. So it's really fun, and it's also frustrating. It's frustrating because you have these moments of epiphanies, and you think you've got it, and you're like, oh my God, and you go and you write like 5 pages explaining this, and all of a sudden it makes perfect sense, and you wake up the next day and you look at it, you're like, what the fuck was I thinking? So yeah, I definitely need to read Wittgenstein stuff, because there is something that I'm thinking about in which numbers might not be what we think they are. Numbers might actually be operations. As a matter of fact, the way I've conceived them, they are operations. The numbers are the number of numbers. So, they are actually the implicit operation of count, which is the implicit operation of sum, which is by the inverse also the implicit operation of subtraction. And that's fascinating. So when the numbers are functions or operations, that's a new way to think about things. So anyways, just to cut this short, yeah, that's what I've been up to. Also, you probably don't know who this is, but check out Chad African on YouTube. He is a philosopher. I consider him a philosopher. A really cool dude who is outside of academia. He quit academia, realized it was bullshit, escaped to India to get away from the crushing student debt. And he makes a lot of interesting videos, just more interesting than my own, talking about interesting topics and controversial questions and things that many people within academia and many people outside academia wish they had the guts to say, and which, oh yeah, he's saying it. So, you know, stuff like identity politics, SJWs, you know, political correctness, the left. You know, he strikes me as a strange fellow who does not sit on the right or the left. I mean, he talks some praise here and there of both sides, but he also shits on both sides. And he shits more on the left because, well, the left is kind of most of his audience. And the audience that needs to hear the critiques of their own points of view. So check him out. He's a really cool guy. You know, he answers pretty much every comment you leave if it's a good comment worth responding to. So yeah, if you're watching, Chad, keep on going, man. See ya.